Alright, so I'm trying to measure the current that the stepper motor back there is drawing, and I'm using pulse width modulation to drive the stepper motor with what's called micro stepping. And so I hooked up this resistor here in series with one of the windings, and I got my two scope probes on there, and in the background it's connected in subtractive mode, so we should see the difference across the resistor. And interestingly, this is what we get. I don't know if you can see it on here, but that is peaking out at about 2.25 volts across that resistor. And the pulse width modulation, you can see, is fading back and forth. It's emulating a sine wave, stepping. You can probably see it stepping very, very slowly. But anyways, so this is my resistor, and the lighting is not very good. But anyways, it's 0.27 ohms. So I did the math, and that means that it's peaking out at about 10 amps. Alright? Something ain't right about that. So I sat there and I thought about all the different possibilities. Maybe I didn't put it in additive mode correctly, or maybe, I don't know what. Any number of things. Kept thinking about it. Well, maybe, I mean, it's an inductor. Maybe the stepper motor winding is an inductor, so maybe it just draws a lot of current initially. And then I noticed something else when I turned off the winding. It floated at 0. Well, that doesn't seem right, because when the motor driver chip, it has a low input, so I put it on low input, that means one side of the chip is plus 12 volts and the other side is ground. So why is it showing 0 current? Well, it's an inductor, who knows? I could have turned this off, it's burning up. It's an inductor, who knows? You know, maybe after it's done, charging and all that stuff, then the current drops way down. It sort of makes sense. So then I took my multimeter and I measured the voltage across there while it was off, and I measured 0.05 volts. And I did the math, and that's about 200 milliamps, which seems about right, which you couldn't see on the scope because it's zoomed out so far. Alright, well, that seems right. How the heck is it drawing 10 amps while it's switching? That doesn't make sense. So, start thinking about it, and you know what? Maybe it's a frickin' wire wound resistor. So I'm not gonna try to film this while I'm changing it. I'll be right back. Now we got our regular resistor in place, and lo and behold, oh, that's not what I was expecting. Oh, that's right, it's connected to ground. Okay, so we're getting a little bit lower than 0 volts. I mean, yeah, so it's negative right now is what it's reading. Let me switch that to positive, or to the signal. There we go. Okay. That looks a little more like what we were expecting. Notice a few different changes too, but one of the main ones is we're getting about 1 volt on either side. It goes plus minus 1 volt. And this is a 3.9 ohm resistor, and you do the math, and that's about 200 milliamps, as one would expect. So, watch out for wire-wound resistors. I think this one says PW5 on it, and I did a quick search, and I think that actually indicates that it's wire wound. So it was acting like an inductor. There you go.